Hello everyone, my name is Mr. Minnick. If you're watching this video, congratulations, you win the door prize. The door prize is 3 really cheesy jokes and 1 gross joke. So I'll start off with the cheesy joke. There was a thief. Oh, you don't know that it's a thief, but this person, this individual, I'm not going to say if it was a man or a woman, this individual went into the grocery store and went to the cheese aisle, and there's all kinds of cheeses in the cheese aisle, right? There's Swiss, there's Gouda, there's Limburger, there's Baby Swiss, my favorite, butter cheese or farmer's cheese. I like both of those. Anyways, there's that one kind that goes really good with Mexican food. When you melt it down, it's nice to dip your tortilla chips in it. So anyways, that's what this perpetrator took a big chunk of and was running out the store, and the store clerk was yelling, "That's nacho cheese!" I told you it would be cheesy. That was a cheesy joke. So today we're talking about relations and functions. We're going to be defining relations and functions. We're going to be graphing relations. We're going to be identifying functions, whether or not a relation is a function or not. The reason we do this is the Common Core Content Standard. I'm not going to bore you with the content standard numbers. You can look those up on your own time. So here we go. First definition, a relation. A relation. So if I'm taking notes, I'm putting down the heading of the notes. It's 2.1, relations and functions. If I'm taking notes, I'm going to write down the definition of a relation. A relation is a set of pairs of input values and output values. I don't really like that definition. I kind of like this one better. It is a set of, how about a set of ordered pairs? A set of ordered pairs. A relation is a set of ordered pairs. Now when we talk about pairs, we're not talking about the thing that when you bite it, it's about the same consistency of an apple. We're not talking about a fruit, the pear. We're talking about pairs, like 2 of them. X's and Y's and A's and B's and P's and Q's and D's and E's. So again, 2.1, relations and functions. A relation is a set of ordered pairs. Everybody all right so far? Okay, I'm about to add a new page to this document. And what I'd like to do is go over the word set real quick. Set implies we must use a special kind of grouping symbol. We got to use a special kind of grouping symbol. I don't know if you all know the name of it. The word set, though, implies that we must use these things. Anybody know what those are called? Those aren't parentheses. Those are, they're not brackets either. They're, Mr. Englehart calls them Franks because they look like a person. Maybe it's a person with a maybe it's Bart Simpson. Anyway, they're braces. They're called braces. Okay, so anytime you see the word set, you really do need to include braces. So just to show you real quick then what a relation is. A relation looks like this. It's got braces, even though you might not draw them that well. That's okay. Ordered pairs. X comma Y, A comma B. Okay, doesn't matter if it's A, B, X, Y, doesn't matter if it's 15, 38, doesn't matter, but there's an input, there's an output. A, X, 15, those are the inputs. B, X, or B, Y, and 38, those are the outputs. Okay, so again, the inputs are this A, the X, the 15, right? And then the outputs are the B, the Y, and the 38. Those are the outputs. Outputs is B and the Y and the 38. So that's what a relation looks like. It's a set of ordered pairs. And the book goes on to say there's 4 different ways that you can represent a relation. And one way is with ordered pairs like that. If at any time this goes way too fast, if you're watching this back on YouTube on the line, you can pause it. Live in class here, I'm hoping that my class will ask some questions. I really wish I had a picture of my friend TJ, because here comes corny joke number 2. TJ and I went riding this weekend on our ATVs, and he loves Mountain Dew almost as much as I do. And he always carries Mountain Dew in his in the little storage container on his Arctic Cat 650. So anyway, we switched ATVs, and I was on his and he was on mine. And he said, "Dude, can you throw me a Dew?" So I did, and it hit him right in the face. Good thing for him it's a soft drink. Okay, so that's 2. There's one more cheesy joke, and then one gross joke coming. So ordered pairs. We can list relations as a set of ordered pairs, as we see on the left: inputs, outputs, x's and y's. And what they've done throughout this is they've taken the same ordered pair over and over again. This -3, 4, 3, -1, 4, -1, and 4, 3. And they represented it in each of the 4 ways. The mapping is kind of cool. The mapping has inputs, outputs, and the arrows that show what input is mapped to an output. Those arrows are important. Table of values. You've probably seen a table of values before. Tables can be vertically, they can be horizontally. It doesn't really matter how they go. And then the graph. So if I'm taking notes, I'm making note of all 4 ways that relations can be shown. They can be shown as ordered pairs, as mapping diagrams, table of values, and graphs. Make sure you know that those are the 4 ways to represent relations. We will have our first quiz in Algebra 2 on Friday. It will be over this material. So, quizzes in my class, I do allow students to use printed notes. So if you're taking notes on a laptop, make sure you print those out before the quiz, because I won't allow you to use an electrical device on the quiz. So make sure you get a printed version of those notes. How's everybody doing so far? I know it's a little warm today. Yeah, last week was pretty brutal. Yeah. So hopefully today's rain will cool things off a little bit. Anybody in here ever catch a snake? Snakes are so cool. Here's the thing about a snake. If a snake is about 2-3 feet long and you grab it by the tail, you can keep an eye on its head, and it's not that dangerous, right? Imagine a snake from the very end of its tail. Imagine if there were 7 heads coming off of that snake's tail. So if you grabbed it by the tail, there'd be like 7 of those things coming at you. Keeping track of 1's not so bad. 2, well, that's a little tougher. 7, forget it. You can keep it. I'm not going to mess with it. We're going to come back to the whole idea of snakes, and imagine if a snake had 7 tails. You'd have a pretty good chance of catching it, and you only got to watch out for the 1 head, right? So that's a pretty good thing. Anyway, we're going to be talking about snakes when it comes to this diagram, because part of what you need to do today is determine whether or not a relation is a function. So, anybody in here ever eat tomatoes? I'm so excited right now. Tomatoes are in season, and what you can do is you can take a tomato and you can slice it open. And you could put it on a piece of wheat bread with some Miracle Whip, a couple strips of bacon, some lettuce, a little bit of salt on there, and some Swiss cheese. And you have yourself a nice BLT. Well, we're talking about a VLT. We're going to talk about that a little bit later. Anybody know what this VLT is all about? Anybody know what this VLT is all about? Algebra 1. Vertical what? Vertical line test. We're going to be talking about that in a little bit too. Okay, so hopefully these are some ideas that are ringing some bells here. Problem number 1 is probably similar to the printed homework you're going to get tonight. There's a plane, there's a parachute, and they're saying, okay, here's this skydiver. Represent this What are they saying? What are they even saying? How could you represent this in 4 different ways? I don't think we need to see that. I think we're going to skip over that. I do want to get to this, and we're not even going to use the one for problem 1. I want somebody to write up what the... Oh, we didn't even talk about the domain yet. Oh my gosh, I'm skipping way ahead. Domain is the set of X values. If I'm taking notes, that's what I'm going to write next. Range is the set of all the Y values. So those are 2 more terms. And here in a second, after you get a chance to jot those down, domain is the set of all the inputs, or X values. Range is the set of all the outputs, or the Y values. After you get a minute to write that down, we're going to see if somebody in here can identify the domain and the range of this relation. Consider this relation. Consider this relation. Here we go. Braces, got those. 3, 4. 3, 5. 3, 6. 4, 7. Okay. So this example here, what we're looking at is we want to find the domain and the range. So the domain, do I have a volunteer to come on down and using the red marker write up what the domain would be? Come on down. Let's see if we get this one right on the first try. My first period class, we didn't do so hot. Second period, we got it. Now there's something that you got to watch for on this. It's not a big deal, but there's something you got to watch for on this. There's something in our volunteer fixed the response. She picked up on what I was saying. There's one other thing that you got to watch for on this, and it's that 3-letter S word. The fact that it's a set means you want to use, the braces. The braces, good. So we got the braces around it. Now our volunteer, Ms. Klein, she started to write 3, 3, 3, and 4. And what I was saying is there's something you got to watch for. If I say something over and over and over and over and over and over and over again, I'm being redundant. I'm being repetitive. Don't be redundant, okay? So when you're writing out the domain, don't be redundant. Don't say the same thing over and over and over and over and over again, even though it's there. You don't have to say 3, 3, 3, and 4. Everybody catch that? Okay, good. So that's the domain. The R to the is-ange. Got a volunteer to come on down and got the R to the is-ange. There we go. All right. So the R to the is-ange. Got to have the braces. Good. 4, 5, 6, and 7. Perfect. Nice. And you do the German 7. Nothing wrong with that. It's all good. Thank you. Good. So it just so happened that these are already in numeric order. There is a Math Excel assignment, and I want you to, I'm tripping over my microphone cord here. I want you to make note of this for Math Excel purposes. Math Excel, be sure to put the numbers in numeric order. In numeric order from smallest to largest. You took that pre-assessment, and there was a question on that pre-assessment about domain and range. And to have gotten it right, Math Excel wants you to put the numbers in numeric order from smallest to largest. So what I mean by that, and that NOS, that's not nitrous oxide, that's my abbreviation for numbers. So for instance, if we had something look like this, 87.5, negative 16.8, and 3.1. Okay? Here, our domain, remember we want to put it in numeric order, smallest to largest. So what would go first for our domain? What do we got? Yeah, so here we go, negative 16, 3, and then 87 for Math Excel. If it's for the homework in here, the written homework, it's fine in the order that it is, but Math Excel wants it in the numeric order. Question? Did I forget the 1? The 1's actually part of the range. The 1's actually part of the range. No, that's okay. That's okay. That's okay. So the range then, the range would be 1, 8, 5. All right. Oh, 1, 5, 8. Good looking out. Thank you. Good looking out. Everybody all right so far? All right. I'm thinking it might be time for a corny joke. It actually has to do with counting. Okay? There was this math professor who moved, and the math professor was very upset, said to his wife, honey, we paid this, insert expletive, we paid this mover $5,000 to move us, and there's boxes missing. I know there was 40 boxes, because I had 5 rows of 8. I know for a fact there were 40, but I'm only counting 39. And she said, well, are you at the house now? And he said, well, yeah, I'm right here. I'm looking at the boxes. She said, well, while you're on the phone with me, why don't you go through and count them one by one? Maybe you know how you are with numbers. Maybe you got hung up. He's like, I teach math. I should know what's going on. She said, no, sometimes just count them. I said, okay, here we go. You ready? She said, uh-huh. She said, I'm going to keep tally while you're counting them. He said, okay. Now remember that there's supposed to be 40, but I'm only coming up with 39. 0, 1. That's the joke. You should be laughing if you get it. If you don't, well then you'll need to know what counting numbers are. Okay, a function is a relation in which each element of the domain corresponds with exactly one element of the range. Say that again. I'm going to write it this way. A relation is a function. A relation is a function if each input has one output. That's a little bit easier way of thinking of it. Another way of looking at it, and I know you're going to be writing that down. So, a relation is a function if each input has one output. A relation is a function if there are no repeating x's. If there are no repeating x's. If there are no repeating x's. Relation is a function if there are no repeating x's. What the heck are you talking about? This doesn't make any sense at all. It will. We're going to get to some examples in just a few minutes, and it will make sense, I promise. A relation is a function if there are no repeating x's. A relation is a function. What's up? A relation is a function if it passes the vertical line test. If it passes the vertical line test. Each input has one output. There are no repeating x's. It passes the vertical line test. There's got to be another way too, and there is. Here it is. A relation is a function if the snake only has one head. What are you talking about? We're talking about snakes in Super Mario World too. In Super Mario World, everything goes to the right, right? Okay. Mr. Mick, this doesn't make any sense at all. You're confusing me. I got this stuff in Algebra 1. I don't get it. Well, let's look at some examples. Let me leave this up for a minute. Does anyone have any questions about anything I've written? Maybe my writing's a little sloppy and you can't read it. Okay. So here we go. If we look at number A, -3 gets mapped to to negative 2. That one input has an output. If we look at 0, 0 gets mapped to 7. The one input has an output. 4 gets mapped to 1. The one input has an output. Is that a function? I'm hearing no. Let's look and see. Let's go split screen on this. Each input has one output. The input of negative 3 has one output. The input of 0 has one output. The input of 4 has one output. Each input has one output. If there are no repeating x's, the x's are the domain, the negative 3, the 0, and the 4. Do any of them repeat? Okay. Passes the vertical line test. We'll come back to the vertical line test. If the snake only has one head, well, what's the snake business all about? There's a snake, and there's a snake, and all the snakes only have one head. Is that a function? It actually is. Number A is a function. Let's look at this vertical line test. Vertical line test. Vertical line test. Basically, the vertical line test goes like this. Says here's this Cartesian coordinate plane. Here's the x's, here's the y's. We're going to plot some points. I'm going to use my creative pen. I use some smiley faces. So there's all kind of points here. And what we're going to do is we're going to drag a line across this. It doesn't have to be a dotted line, but what happens, it is supposed to be a vertical line. It is supposed to be a vertical line. If that vertical line goes through more than one point at once, this is a failure of the vertical line test, and it's not a function. Okay? If we look at that particular instance, that fails the vertical line test. That relation is not a function. You might say, well, what's this look like with some points? Well, let me show you with some points. The coordinates here might be 2, 7, and 2, 8. Do you see how there's repeated x values? Is it starting to make a little bit of sense now? Let's look at this with the map. With the map, we're going to say, here's my input, here's my output. With the map, we're going to have 2 being mapped to 7. That's a one-headed snake, right? But 2 gets mapped to 8. Does that idea of the snake having 2 heads now start to make a little bit more sense? Okay, good. Everybody with me then? Question? So the question is, how do these all relate? Yeah, if you do the check with the vertical line test, you don't have to do the other ones, but you can if you just want to double check. Yeah, so if it passes a vertical line test, if it doesn't have any repeated x's, you know for a fact that it's not going to have 2 heads off the snake. Yeah. So the question is, if you had to pick one of those methods to test, what would it be? It depends on how the relation's given. If the relation is given as a map, you'd think about the snakes. If the relation is given as ordered pairs, then you'd look for repeated x's. If it's given as a graph, you'd use the vertical line test. Great question. Okay. So if we look at number B, hey, we're given ordered pairs. So we're going to look, are there any repeated x values? What x value repeats? Oh, so is this relation a function? No, it's not. Because graphically, when we graph this, what would happen is we would have the point 4, 1, and 4, negative 1, so that would fail the vertical line test. Some people might want to visualize the vertical line test all the time. Either way, this is not a function, no. And it's not because of those 2 points right there, right? Because of that x value repeating. Everybody all right with that one? What do we think about number C? Is it a function? No. Why not? 2-headed snake. Good. We getting the hang of these? Cool. Let's try one more. Is this a function? 3, 5. Oh, I want parentheses, not those. Rad 9, rad 25, and then 4, negative 1. Who says yes? Who says no? Let's go to the graph. This first point is the point 3, 5, right? Everybody okay with that? It's 3, 5? So let's go 1, 2, 3, 1, 2, 3, 4, 5. So we plot the point 35. Fair enough? Okay. This next point, what's the square root of 9 simplify to be? 3. What's the square root of 25 simplify to be? So this is the point 35. Let's plot the point. The point 35 is the point 35. And then 4, negative 1. 4, negative 1 is going to be down here somewhere. Is this thing going to pass the vertical line test? So is it a function? It is a function because that's a trick question. But this is a function. This is a function because it's the same point. So that whole thing about repeated x's, you got to consider if it's the same point, it still might be the same. It still might be a function. But when we look at those repeated x's, are the y's different too? Does everybody get that? All right. Cool. Well, we're on a roll. We're doing pretty good. We talked about the vertical line test. So let's look at number A here. What do we think? Is number A a function? No, it fails the vertical line test. How about number B? How about number C? C is not because those 2 points right there. Good. How about number A at the bottom? A at the bottom's a no. How about number B? Yeah, B's good. How about C? So far, so good? Well, now we get to talk about something that's really scary. We get to talk about something that's really scary. We get to talk about F notation. F notation. Many of you know I play guitar. I'm after a new guitar, and I don't understand why they call some of the guitar bodies, they call them F holes that they drill in them. Anybody ever see the semi-hollow body guitars? They have an F hole drilled in them. Anyway, this is called F notation. F notation confuses a lot of people. Don't let it confuse you. Its intent is to save space, save room, save time, save writing. Mathematicians are all about writing stuff in as few characters as possible. Okay? So back in the day, somebody might say, for the function y equals 2x minus 5, comma, find y when x equals negative 2. That's a lot to write, isn't it? What you would do if you had to actually do this is here's the process of finding this. Here's what you do. You'd say y equals 2 times negative 2 minus 5. So you'd say y equals, what's 2 times negative 2? Negative 4, good. Negative 4 minus 5. So y equals negative 4 minus 5. Think about the number line. You go left 4 and then you go left 5 more. So that's going to equal what? Negative 9, good. So that's the process you would do to do all that. Everybody okay with that? That's a lot to write. Procedurally, when you use F notation, you're going to write the same amount in finding stuff. Actually, you might write a little bit more. But in writing up the directions, watch what F notation looks like. Instead of saying for the function, with F notation, instead of saying for the function, all we're going to do is write this. For f of x equals 2x minus 5. The fact that we're using F notation implies that it's a function. Just the fact that we're using F notation implies, you know what, this is a function. So for this function, f of x equals 2x minus 5. Now, when we do this other part, and this is where it gets a little confusing, instead of saying find y when x equals negative 2, instead of saying all that, all we're going to say is this. We're just going to say find f of negative 2. Find f of negative 2. And that's not read f times negative 2. That's read as f of negative 2. As far as what you do, you're going to do the same thing. You're going to say, so f of negative 2 is 2 times negative 2 minus 5. So you're going to say, okay, so f of negative 2 is negative 4 minus 5, and so f of negative 2 is negative 9. You do the same steps on the left, and you guys know well, I won't say names in the video, but somebody in my second period class asked a great question. They said, so let me get this straight. They said, so what you're doing right here, when you write f of negative 2, are you saying f times negative 2? No, I'm not. They said, is that the same thing as y? Yes, it is. This is the same thing as y. This is the same thing as y. This is the same thing as y. Does that make a little bit of sense? I hope. Okay. In a minute, we're going to try another one. Well, in a second. Here we go. For f of x equals 19x plus 48 x squared, find f of, I gotta watch when I do this. Find f of that. Find f of that. Okay? So what it means is, in place of x, we're going to put that. Now, if I wanted to find f of 2, it means I would replace x with 2. If I wanted to find f of negative 6, it means I would replace x with negative 6. But since I'm finding f of that, it means what I'm going to do is I'm going to take that and plug it into the function f in place of x. So what I'm going to do is I'm going to take that and I'm going to f it. That's what it means. It just means insert it into the function. Okay? Got to be careful when you say that. So, f of that, all it means is let's go to this function and let's replace x with that. So it's 19 times that plus 48 times that quantity squared. And that's it. That's it. The notation seems kind of abstract, I know. But that's all you're doing. How's everybody doing? All right? So sometimes we're going to be g'ing some stuff. Sometimes we're going to be putting it into the function f. Okay? I know that looks really weird, doesn't it? You're going to go home, what'd you learn about in math class? Oh, look at my notes. It says f that. Remember, that's f of that. Okay? All right. Everybody okay? All right. Well, some of you are wanting this other joke. Well, I want to show you how to use the calculator to make life easy for you. Watch this. Now, you could do this by hand. F of 0 would be 5. That one's not bad. But what I'm going to do is I'm going to bring up my TI Inspire, and I'm going to show you how using lists, using calculators, using tables on calculators is going to make life really easy for you. This function f of x is negative 1/4 x plus 5, I think. It's going to take a minute. While this is loading, I'll go ahead and tell the other joke. It's gross. Anybody ever hear of constipation? It's when you get backed up in your guts. It's kind of disgusting. Anyway, so I told a joke earlier about the math teacher that was counting. And this one, did you all hear about the constipated mathematician? You know how he solved his problem? He worked it out with a pencil. Okay, so this is just about loaded. This is just about loaded. F of 0, I said, was 5. That one's not too bad. Calculator's taking forever to load. The calculator taking forever to load reminds me of the one time that Jesus and the devil had a computer battle with programming, but I'll tell you that one another time. Okay, so f of 0 is 5. All right, everybody down with that one? And f of negative 3, you could probably even do that one in your head, right? Negative 2 times negative 3 is 6, and 6 of 5 is 11, so that one's 11. Now the one with the 4th, you might not know that one. Negative 2 times the 4th is negative a half. 5 plus negative a half, that's 4.5. So you might say it's 4.5. I don't like mixed numbers in this class. 9 halves is a better way to write that. 4.5, if you write 4.5, it's not the end of the world, but I really like improper fractions. Get used to them. So I just want to show you real quick on the calculator how we can do this. Check this out. I am going to say to the calculator, define f of x as the function negative 2x plus 5. And it says done. Good, thank you. Now what I want to do is watch when I type in f. When I type in f, see how it's bold? It's bold because the calculator recognizes it as a defined function. I want to find f of the following items. Negative 3, 0, and 1/4. I'm going to make a whole list of these things. Negative 3, 0, and 1/4. Watch this. Bam. You like that? Isn't that pretty sweet? So anyway, I probably better take a picture of that and capture that into the software. And then there's one more thing we need to talk about today, and that'll be it for the day. So I need to capture that. Hopefully that goes. There we got it. All right. Everybody all right so far? Okay. Yeah, question. Can you use a calculator on the computer for your homework? Absolutely. Yeah. And if you haven't got Desmos yet, you'll probably want to add that to your Chromebook. I wouldn't recommend using it as a crutch, but it's definitely a great tool. Desmos. It's cool what it says. It says it's a beautiful, free graphing calculator. Check this out. Desmos. So our function is negative 2x plus 5. And I do believe that there's a way to insert a table here. Graph settings, zoom. Let's see. I know there's a way to insert a table. I don't remember how to do it, but I'm pretty sure there's a way to insert a table. Oh, there it is. Convert to table. Ha! Ha! Look at that. What do we have? 0, 5. I don't know if there's a way to set up the table, to change the table settings. I'm sure there is. But anyway, yeah. Cool. How's everybody doing so far? All right? Good. In the homework and on the quiz, you're going to actually have to graph some of these things. If you had to graph f of x equals 1/4 x plus 5, 1/4 x plus 5, and you were given a multiple choice, I would hope that you would realize, first of all, the slope of this thing is greater than 0, which means the line's going to do what from left to right? Rise or fall? It's going to rise. Good. And also the y-intercept of this is 5, which means the graph is going to cross the x-axis. It's going to cross the y-axis above the x-axis. Does that make sense? So I think at this point in time, you should be able to pick one of those out of a multiple choice graph. So I'm not even going to spend time with those. Last thing, I promise. And then there will be a written assignment that I'll pass out to you. So the domain and range of some of these other kind of graphs, a lot of people, pre-calculus students, algebra 2 students, for whatever reason, they struggle with something that looks like this. They struggle with something that looks like this. Let's suppose we've got this parabola that has a minimum value, that occurs at the origin. Okay? The domain of this is actually quite, well, the domain and range are both pretty simple. But I think the range is a little bit easier to pick out than the domain. Remember what domain and range are. They're all the y's, all the x's. The domain includes 0. This thing probably goes through the point 2, 1. So the domain also includes 2, right? This thing probably goes through the point 3 something. Oh, I put the parenthesis in the wrong place. But it goes through 3 something. So it includes a 3, right? Well, guess what? It includes all the points between those as well. So you mean it includes 1? Yep. And you mean a half's in there? Yep. This is going to take a long time to write them all, isn't it? What about over here? Well, yeah, it goes through -1 something, right? So how could I express that domain? Anybody got any ideas? I'm seeing the infinity symbol. That's a good start at it. On the largest, the maximum, you can't get to infinity. So yeah, you could say infinity, and then on the negative end of things, we could say negative infinity. And if we use this notation, we'd say from negative infinity to positive infinity is the domain. Perfect, nice, good. So that will work. Another way to say this is all real numbers. All real numbers. Okay? And for now, using that language, all real numbers is probably going to be good. Negative infinity to infinity is good too, though. The range, real quick, and then this will be it. The range actually goes from 0 to infinity, like this. And we'll talk more tomorrow why I used a bracket on the 0 instead. It's all real numbers greater than, or equal to 0 for the range, okay? So again, tomorrow we'll talk about why I used that bracket on the 0. It's been real, it's been fun. I got to stop this video so I can pass out the homework. I hope everybody has a terrific day, and I'll check you all later.